All right, so hopefully, let's see. There we go. Can everybody see that okay?
Yes.
Hopefully. Yeah. All right. We'll take that as a yes. All right, so I'll keep my eye on the chat as always. Let's go ahead and get into it though. So functions. All right, so when we look at functions, the first part of them is going to be linear functions. Like we said, not much different than the classic y equals mx plus b of slope-intercept form that we learned about when learning about linear equations and the rest of the heart of algebra sort of subsection, or algebra as it's called in the ACT. So when we have f of x equals mx plus b, f of x has just replaced y. They are synonymous. That's a good thing to keep in mind. And that's the difference of what we call function notation. So it's worth putting that down. That is function notation. It just says that we are now writing y as a function of x, meaning y is now thought of as the result of plugging in a given x value, as opposed to just sort of a separate entity in and of itself, right? It is now a resultant of x. That's what function notation really implies. So that's the point of changing it. So when we look at each of the individual variables, it's not too much different. M is still that slope, right? Just like it was in a normal linear equation. B is still that y-intercept. Now f, though, this one is key. F is the name of the function. Because the reality is about function notation, it can be any letter outside of that x, right? So it could be most commonly it's f of x, g of x, or h of x are the ones that these tests really like to give, but it can be any. It could be d of x, it could be b of x, z of x, doesn't matter. Any letter, any of them work, but all that really is the name. All that does is allow us to realize, okay, when we're talking about a given function, this is the function f. It's just an identifier. Input versus output are actually another two other terms for x and y, or x and f of x. So those are good to know. I used to actually, they're one of the video lessons associated with the course is the many names of x and y. It's a really quick video, but it is helpful because it talks about x and y being x and y, of course, x and f of x, input and output. And then another important one that you're going to want to keep in mind as we talk more about functions is domain and range. So that those respectively are x and y. And typically domain and range actually refer to all of the x and y values respectively, right? So all of the x's or all of the y's, but we can ask for, or a question could ask for, a single value of the domain or a single value of the range, right? So then we would be talking about a single x or a single y. So that's domain and range. That's the sort of many different names that those two variables take on when we look at functions. Lastly, we know that a function is a function because it doesn't have any repeating inputs, no repeating x's, right? And what we mean by that is on a table, let's say, right, if you had x, f of x, you had a table and it was like 1, 2, then the point 2, 4, then the point 2, 6, and then 3, 6. Like, okay, there can't be, y's can repeat, that's fine, but each x should have a unique y, which means when this x has two different y values, this is no longer a function. And the reason that is if you were to put that graphically, it would fail what's called the vertical line test. And the vertical line test is how we test if something is a function. So something like parabola, right? It says that if you run a vertical line through any point, it's only going to hit that function one time. Makes sense. However, if you had something like this, you see a vertical line would actually hit it twice. So again, if it hits it more than once, hits a function more, if a vertical line at any point hits a function more than once, then it's not a function, which is why if you, and this is just sort of a conceptual thing when we talked about, remember when we talked about different slopes, we talked about ones like this, flat lines being 0 slope, but then we said one vertical lines were undefined or no slope at all. Well, think about it. What perfectly fails the vertical line test? A vertical line, right? And an equation in the form of x equals something. that's going to be a vertical line, which perfectly fails the vertical line test, which of course is not a function. That's why we get an undefined value for those when we try to find slope. All right, so now we'll get a little bit of practice with functions. Let's go ahead and try these. The idea of linear function. So this one, we have a linear function that's graphed, or it's really more of a piecewise function actually, but it's got linear sections. The complete graph of f is shown in the xy plane above. For what value of x is the f of x at its minimum? So this is a great point I always like to bring up, because we sort of go learning as we go here. So maximum, when we talk about maximums and minimums, they are the highest and lowest points on a graph, right? But for our y, or for a function, our f of x function, right, they are y values. They are always, always, always y values. And I can't stress that enough. So if you're taking notes, definitely take notes on that. Maximum minimums are the highest and lowest y values of a function, okay? They are never referring to an x. So we are referring to a vertical point when we talk about a maximum or minimum. So this one asks, if we look back now, for what value of x, so what value of the domain, what input value is f of x at its minimum? So this one's kind of a multi-part. First, we have to find out what is the minimum of f of x. So when we talk about that lowest y value, what is the minimum of f of x? Good, -2, very good, right? -2 is that minimum y value, very nice. And then we ask the question, that looks like we we jumped ahead a step there, perfect, is when this, so yes, this is y value wise at -2, which is what I was asking, right? Great. And then we ask, okay, so when it's at that y value of -2, what is the x value? And if we look, 1, 2, -3, right? So there you go. So that's actually the point, -3, -2. So to say when it's at its minimum, which is -2 for the y, what is the x? That x is -3. So B would be our correct answer there. So very nice, guys. Good job with that. All right, let's take a look at the other one. Some values of the linear function f are shown in the table above. Which of the following defines f? All right. This one draws on an old idea, one we talked about in actually the Heart of Algebra lesson, or one of them, right? The linear equations lesson. You'll have to use the slope formula. That's what would be most helpful, right? When we have multiple points and we're referring to a linear function, or we have a table like this, we always want to try and find that common slope, right? So that slope formula is, to remind you, if you don't have it written down or memorized, m equals y2 minus y1 over x2 minus x1. So go ahead and use that to find the slope of this function, right? Because these are just points from the function. So anytime we have more than, we have 2 or more points, we're always going to just plug in to find the slope, being that it's a linear function, right? Yeah, so we can use that to find the slope. And then actually, it looks like each one of these answer choices has a different slope. So it should give us our answer. Give everybody a second here. All right, so hopefully we plugged in. So if we plug in 2 points, let's call this first point 1, let's call this point 2. Then the y2, or the y value of the second point, is going to be 13 minus the y value of the first point, which would be 5, right? F of x is y. 13 minus 5 over the x value of the second point, 3, minus the x value of the first point, 1. 13 minus 5 is 8. 3 minus 1 is 2. 8 over 2 simplifies to 4. So if our slope is 4, and we now think about y equals mx plus b form, or slope-intercept form, which one then would be our correct answer? Which of these equations? Perfect. C, definitely, right? Yep. So we don't even have to know that the y-intercept was 1. All right. Very nice. All right, perfect. So now let's go to these. So we've got the table above gives the values of the function for several values of t. If the graph of f is a line, which of the following defines f of t? All right, so same thing. You're trying to deduce a function here based on those points. Remember, use 2 points to find the slope. And remember that when that one of these points, the other part of slope-intercept form, right, is the slope. Excuse me, of course, is the slope, but the other part is the y-intercept. And you've actually, in this case, you've been given the y-intercept as one of your points. So use that as you will as you're calculating here. So find the slope because you've actually already been given the y-intercept. All right. So if we calculate slope, we can pick 2 points. I would probably pick these two, 1 and 2. So let's do it again. Same thing. Y2 is 3 in this case. The y value of the second point minus the y value of the first point would be 1 over the x value of the second point, 2, minus the y value of the first point, 1. 3 minus 1 is 2. 2 minus 1 is 1. 2 over 1 is equal to 2. So our slope is 2, which means we know a and b is out, right? Is y equals mx plus b. 2 should be in the position of m, which would be right in front of the t in this case. So that's gone. Now we have to ask, what is the y-intercept? Well, if we look right here, 0, -1 is a point. Think about where 0, -1 is. It means no movement left or right. It's just down 1. So that's still on the y-axis. That's better drawn would be that. And that would make D our answer. You have that positive 2 as a slope, -1 as our b value. All right, try this one. Can we Absolutely. That's a great question. Absolutely. You could pick any 2 points. You could have done 0, -1, and 3, 5. Absolutely. And you could have even, and it doesn't matter what order they're in either. You could do 3, 5 as 0.1 and 0, -1 as 0.2. Like let's plug that in, for instance, if we did exactly that. -1 would be y2 minus y1, which would be 5 in that case, over, and you could do, let's see, y2 then would have been 0 minus y1, which would have been 3. -1 minus 5 is -6, over 0 minus 3 is -3. -6 divided by -3 is still a +2. So yeah, that's a great question. And we can pick any 2 points. Usually, right, if it just gives us 2 points, we don't have the choice of, like we don't have this many options. But yep, it can be any 2 and it can be any order. You just have to maintain knowing which one is you've picked to be 0.1, which one you've picked to be 0.2. But as long as you stick to that, order doesn't even matter. Yeah, of course. Yeah, always, if anybody ever has questions, it's always great to ask, because sometimes you answer a question somebody else may have too. So that was a great one. All right, yeah, let's get to the next one. So if 10 plus x is 5 more than 10, what is the value of 2x? So this one's kind of equation building, and it has you solve it. The equation itself isn't too difficult, but maybe building it is. So I'll give you a minute for this one. What are we thinking on this one so far? I'm wondering if it's because it's like a little bit weird, or it's because it was like really, really easy. What are we thinking? All right. If there's nothing, we'll go ahead and start going through it. So let's take a look. So 10 plus x is 5 more than 10. So that says 10 plus x is equal to 5 more than 10 would be 15. So that's the initial equation. Now go ahead and solve for this. And keep in mind what the actual question is asking. That's always the key with these. They like to kind of, it's like sort of like a misdirection magic trick. They kind of like to lead you over here and then make you forget what was going on over here, which is the real question. Good. So if we solve, there we go. If we solve for x, yes, x does become 5 because we subtract the 10 from each side. Oop, and x is equal to 5. But then what did the question ask, right? It asked for 2x. 2 times the 5 will be c. 10. That's very, very common. So always, and this is a great time to kind of review that idea. Is always just be cognizant of what the actual question is, because they'll do it on problems much more complex than this and have you solve all these different things. Like let's say you could do one on quadratics, and we'll see obviously when those ones where we have to factor for quadratics and stuff like that, where you could use, you either are factoring or maybe you're doing the entire quadratic formula, and then you're like, perfect, I got my zeros or my answers to be 2 and 3, and you're like, awesome. And you pick one or something like that, and you go, okay, perfect, 2 is the first one you see, you pick it. When in reality, the question asked, what is the sum of the solutions, right? So you would have had to add those answers, 2 and 3, to get 5 or something like that. It's very common for them to, for the makers of either of these tests to do something like that. All right, nested functions. And we didn't take the second to talk about them, where you saw that slide and literally said nested functions right in the middle. I should have reviewed it then, but we'll talk about it now. Nested functions are just functions within other functions. So you see, in this case, we've got like f of g of 2x, that kind of thing. Well, we start, the thing with nested functions is, and if you're taking notes, this is what I want you to write down about them, is, well, one, that they're defined as just a function within a function. A function within a function. And then the key with them is that we always start from the inside out. All right. Meaning we would start with the innermost function. So we're plugging, like in this example from that one right there that you'll see, we're plugging in 2x for x in which function? The g function. And then when we get that answer, that y value, that whole thing is going to be plugged in as x for which function? The f function. All right. So we will do this one together. So I'll show you what I mean. So let's go ahead and do that. All right. So f of g of x, that means, so now we've got f of x, we see one function, and then we see negative 2x plus 1 is g of x, so two unique functions. So now normally f of g of x would just be plugging in the answer for g of x into f of x, but now it asks for 2x, which means now anywhere we see x in the g function, it needs to be substituted for 2x. So if we do that, it'll look like this. G, and if we wrote it in full function notation, g of 2 of x, or sorry, g of 2x, I should say, g of 2x is equal to negative 2 times, and now instead of x, we have 2x plus 1. All right, so when we get that, negative 2 times 2x, negative 4x plus 1. So there's our value. G of 2x is equal to negative 4x plus 1. Now that we've got that value, you see that it's all, that whole thing now is within the parentheses, which means it's x for the f function. All right, so now that whole thing was nested within the f function. So now anywhere we see x in the f function, we have to plug in negative 4x plus 1, this whole thing. So if we look at the f of x function, let's go ahead and plug it in. X squared, instead of x, it's going to be negative 4x plus 1 squared, because it took the place of x, minus 4. And now we'll have to FOIL because we have two binomials. And this is a good time to mention FOILing. So FOILing is just a method of, if you're not familiar with it, is a method of multiplying binomials like this, which is just things that have two terms. Polynomials have two terms. It stands for first, outer, inner, last, and it just talks about what terms we should be multiplying. So the first two, so in this case, negative 4x times negative 4x, which would be 16x squared. All right, and then the outer, which is in this case negative 4x and 1 out there, so minus 4x. The inner, which is again 1 times negative 4x, so minus 4x. And then the last two, which would be 1 and 1, which multiply just to 1. And don't forget, we have, in our case, then minus 4 out there too, so minus 4. All right, so if we combine like terms, 16x squared, no like terms there. These two can combine into negative 8x. 1 and 4 combine into minus 3. And there it looks like B is our answer. 16x squared minus 8x minus 3. So do we see that idea of plugging each thing in, right? So if it's in the parentheses, we start on the inside, 2x went into g of x as the x value, right? And then when we got that whole thing now, that y value that was nested, that y value became the x for the f function because it was within the parentheses. All right, so just go ahead and give the next one a try now. It's a nested function. It's not quite as difficult as the last one, but it is technically still a nested function. So give this one a shot on the right there. Good. We'll give everybody one more minute on this one, but it's looking good. Looking good so far. You said that one was much easier than the other one. All right, so here we go. If we do this one, 3 times 2x minus 3 equals 33. What is the value of 2x minus 3? Well, then now the nice part is we know all we really need to do is isolate this whole thing. It's only one step. Divide by 3, divide by 3. And we see that 2x minus 3 is equal to 11. So this is one of those ones where it pays to read the full problem first, because obviously inherently we would want to solve for x, but in one like this, it's not even necessary. So there we go. And I'm sure the beta answer is, let's see, it's 3. So 3 would be 14. Divided by the 2 would be 7. Yeah, so x is equal to 7, which is why they put it there. So if you really do solve all the way down for it, it's tempting, but it's not what it asked for. All right. More functions. All right. Give these a shot. And the xy plane, line L passes through the points 0, 3, and 1, 5. Which of the following is an equation of line L? Now we're given 2 points. Oh, can you? Yeah. Yep. Okay. So this one asked for what is the value of 2x minus 3? Well, 2x minus 3 is already in that form. Like we don't even have to solve all the way down for x. We're just trying to isolate this whole thing. Well, if we're just trying to isolate those parentheses, there's only one thing we have to do to this, which is get that 3 to the other side. How do we do that? 3 and that whole thing are being multiplied. We do the inverse operation like we do with normal algebra. Divide both sides by 3. And now we have 2x minus 3 is equal to 11. And now normally we would continue to solve for x, right? But in this case, we don't need to because the question asked, what is the value of that whole expression, 2x minus 3? So we just have to leave it as that, 2x minus 3 equals 11. So the 33 minus or divided by the 3 is how we got to 11. Perfect. All right. Oops. All right, in the XY plane, line L passes through the point 0,315, which of the following is an equation of the line? So if we plug in these points, right? So I'll do 1 and 2. 5 minus 3 over 1 minus 0 would be 2 over 1 for the slope, or 2. So these two are out. And then if we look, 0, 3 is the y-intercept, because we said that's what y-intercept is. It's 0, y, 0 something is the y-intercept. And that would be a positive 3. So yeah, C would be the answer for this one. Hopefully everybody feels good about that. All right, what are the solutions to this equation? 9x over 9 is equal to x over x minus 2. For one like this, y'all, I would just plug in. That would totally be my suggestion for this. Plug in each of these values and see which work, see which don't. How will you know, you ask, right? Because you could solve this one algebraically. But the reality is you would have to, because if you cross multiply that 9x to the x minus 2 that's on the bottom of the other side, you would have a quadratic, which means that in and of itself is going to have two solutions, possibly one that's real and one that's not. So the easiest thing is just take the answer choices, plug each of them in, see which work, see which don't. And by work, I mean creates a true statement. So if it makes an equation that is truly one side equals the other, then it works. If it makes, 27 equals 9, well, that's not a true statement. So no, it doesn't work. You know what I mean? So that's how we test when we plug in functions into an equation like this. All right, so if we plug in, it's like we're getting 0 and 3. If we plug in 0, 0 just becomes, if it simplifies, ends up being 0 equals 0. So we know 0 works, which automatically eliminates A and D. Now we just have to see if 3 works or 1 works. If we plug in 3, 3 times 9 up there on the top of the left one would be 27. 27 over 9 is 3 is equal to x is 3. So 3 over 3 minus 2, 3 over 1 is also 3. So yes, 0 and 3 work, which makes C the answer. Perfect. All right. Let's go to this last one. The complete graph of the function f and a table of values for the function g are shown above. The maximum value of f is k. What is the value of g of x? So like this one, this is actually two different functions graphically. I'm going to try and give you a little extra time on this one because I don't think we will make it through the entire quadratics lesson. So what I'm actually going to do is I'll revise the schedule and we'll fit quadratics in as a separate day from now on. So this is good. This is the first time I've tried to combine them, and I don't want to obviously cut you short for quadratic. So we'll make it a separate day for you because it is super important. The idea of functions and quadratics are pretty similar weight wise. So yeah, we'll do that. So that's my point. I'll send out a revised schedule. So don't worry, you won't miss quadratics. We'll still do it soon. All right, the complete graph of, okay, so we have the question, is it g of k or g of x? Here we go. Well, remember that g of x doesn't really necessarily mean x, right? It just means g of the input, and the input can be anything. In this case, it's calling it k. So that's a good concept, right? To understand that when we say g of something, it just means what are we plugging into that function. So in this case, it's k. But we're told that k is the maximum value of f. And we already said maximum minimums are y values. So we're looking for the highest y value of the f function, which if we look at the names, right, here's g, here's f. The graph is f, the table is g, two different functions. So we're finding the maximum of f, and that is the input for the g function in this case. So if we look at what is the k value, the maximum of f is 3. So now if we plug in 3 as the x value in the g function over here, let's find that x value of 3. What is the y value with that? 6. So the final answer to this one would be 6, or B. So k was 3, but then when it became g of k, or g of 3 was 6. So this one was like sort of the ultimate function notation, multiple functions. It was technically a nested function. It kind of combined everything. You okay with that idea? Any questions on that? Yeah, these ones are tricky and they're designed to be that way. Yep, and they're great at putting answers that are one of the answers that are in, one of the steps to getting the final answer. They love to include those as the final answers or options for the final answers. And of course, in this case, yes, it is very easy to fall for this one. All right, so hopefully everybody feels okay about those. I'll go ahead and stop the screen share, stop the recording.